Good morning, students. Let me continue with another important topic in water technology. We have been seeing with the different types of conditioning of water. Before going in detail, what do we mean by conditioning? Conditioning is the process by which we remove the hardness causing salts from boiler feed water. Because of the presence of certain salts which cause hardness, it may give rise to the various boiler troubles, namely scales and sludges, priming and foaming, caustic embrittlement, and boiler corrosion. Hence, there is a need to go for conditioning of water. There are two types of conditioning: internal conditioning and external conditioning. Internal conditioning takes place inside the boiler with the help of boiler compounds. And already we have seen what are the different types of internal conditioning with respect to the nature of the boiler compounds. In this class, let us talk on external treatment of water, that is also known as external conditioning. This takes place externally, that is outside the boiler, before feeding the water into the boiler. And this process is also known as ion exchange process because the principle involved during the process is ion exchange reactions. And this is also known as demineralization. Now, what do we mean by demineralization? That is the removal of minerals. That is, we are going to remove both the hardness causing cations like calcium, magnesium, etc., and hardness causing anions like chloride, sulfates, etc., from water. Thus, demineralization is the process of removal of hardness causing cations and anions present in the water. Usually, the cations are replaced by hydrogen ions H plus and anions are replaced by hydroxide ions OH minus. Now, how do we carry out this particular process? Now, for means of ion exchange, we are using a particular uh, substance that is known as resin. What is a resin? Basically, it is a organic material and they are in general insoluble, organic, high molecular weight polymers, and they are cross-linked in structure, microporous in structure, and capable of exchanging H plus ions and OH minus ions with the hardness causing cations and anions which are already there in the water. You can see some of the examples of the resin in the diagram. Now, what are the characteristics of the resin? And I already told you, it is a organic molecule, polymer in nature, and it has a long chain. Polymer means it must be having a long chain, microporous in structure, that is, it has the fine pores on its surface, and it involves cross-linking, insoluble solid substance, and they have a replaceable functional groups. On the basis of ions present in the resins, they are classified into cation exchange resins and anion exchange resins. With respect to the use of resins, the device is classified into, otherwise, the device consists of two columns or two parts. One is known as the cation exchanger Another one is known as anion exchanger. Now this cation exchanger is packed with cation exchange resin. And the nature of cation exchange resin is given in this particular slide. The first one is they consist of acidic functional groups. That means they have replaceable hydrogen atoms. Thus, they are generally represented as RH2, otherwise RH plus. They are capable of exchanging their H plus ions with hardness causing cations, that is calcium and magnesium, which is there in the water. You can see the sulfonated coal and sulfonated polystyrene as shown in the picture, which are known as cation exchange resins. Anion exchange resins. What are anion exchange resins? They are again a long chain polymers, and they consist of basic functional groups. Hence, they are represented as ROH or sometimes RNH2. And they are capable of replacing their hydroxide ions, OH minus ions, with the hardness causing chloride and sulfate ions than in the water. Again, in the picture, you can see the quaternary ammonium salts and urea formaldehyde, which are well-known anion exchange resins. Now, we go with the procedure. Now, they take the hot water and the water is allowed to pass through a cation exchanger and then over anion exchanger. That means the hot water is allowed to pass through cation exchange resin. The cations are removed and the water which is free from cations is allowed to pass through anion exchange resin. The anions are getting removed and you will be getting a water which is free from both the cations and anions. We will see the process in detail. So when the water goes through the cation exchanger, otherwise cation exchange resins, can you see the slide? You have, suppose if you have calcium ions in the water and it is removed by cation exchange resin, thus H plus come to the place of Ca and Ca go to the place of H plus. That is, you are getting R2Ca plus 2H plus. That is, calcium is getting retained in the resin itself. Similarly, if you have magnesium ions, here the magnesium ions are getting retained in the resin itself. So you are getting free water from which is free from cations and anions. It has H plus. Now, the calcium and magnesium free ions are allowed to pass through a anion exchanger. So still you have chloride and sulfate ions to get removed. So what happens in anion exchanger? That is, you have a resin which has the replaceable OH minus. Now this OH minus will react with Cl minus ion than in the water. So the Cl will go to the place of OH and OH becomes free. That is, the product is RCl. That is, the Cl is retained by chloride ion is getting retained in the resin itself. Similarly, in the next reaction, we can see how the sulfate ions are retained in the resin itself. So in the cation exchanger, you are getting free H plus ions, and in the anion exchanger, you are getting free OH minus ions. Now, both the ions are released from cation and anion exchangers. They combine with each other and they produce water. This water is free from both the cations and anions. That's why it is also known as demineralized water. So can you see the diagram? They take the hot water and is allowed to pass through a resin, okay? And that is it packed with H plus ions. Now, as it passed through the resin and it is free from calcium and magnesium, you have only chloride and sulfates, okay? Now, this water is allowed to pass through a second one, that is anion exchanger. And this has a replaceable OH. So the OH comes out of the anion exchanger and sulfate it's retained by the resin. And thus we get H plus OH minus as H2O, which is known as demineralized water. At one point of time, we can realize that both the cation and anion exchanging resins are exhausted completely due to the continuous deposition of calcium, magnesium, chloride, and sulfate ions. So, it is must to regenerate the resins. Usually, the spent cation exchange resins are regenerated by washing them with acid, dilute acids, where you get back the free RH in the resin. Similarly, the anion exchange resins are replaced by washing them with the rinsing them with the alkali so that you are getting back the OH minus ions in the resin. Thus, both the resins are regenerated. So, students, so we have clearly seen the process of demineralization. I hope the concept is clear, and as we know, the water treatment has become mandatory. As per the survey, they say that only 1 drop of water is fit to be consumed by the human beings. So, when you want to lead a healthy domestic life and problem free industrial life, then you have to go for water treatment. And one such process is demineralization. Thank you.